I work with Pennsy Supply. We are a division of CRH, which is in the building materials industry. We're an aggregates production company. We also make ready-mix concrete and hot mix asphalt, and also industrial minerals with the high calcium limestone that we mine. Pennsy Supply is based around Harrisburg, Pennsylvania. We're about within a 1-hour radius, our plants around Harrisburg. I've been about 30 years in industry, a few more years in consulting engineering. They put the passion for in. My current role, Director of Operations Support, which is just a fancy term for engineering and maintenance. I do cover both, as well as CapEx projects for Pennsy. My experience is in maintenance, project management, and operations, both at Pennsy Supply and refractories manufacturing before that, construction before that. A passion for leveraging new technologies. I do like new technologies. I'm always seeing what's out there that'll help us out. We are a very old industry. Pennsy Supply was founded in 1921. We are mining at sites that were opened in the 1800s still. So wherever we can find a way to leverage a little bit of improvement and profit, I'm going to look for it. Reducing operating costs. Pennies per ton is the difference between success and failure. So again, everything we can do to try to chisel away at our costs is something we're going to shoot for. Improving reliability, as has been mentioned many times already today, that's what we're after. It improves everyone's lives at work as the reliability goes up, and enhancing efficiency. So again, there's a lot of potential wins out there that we're always trying to shoot for. My experience with machine health. Again, we're in an advanced aging industry, let's just say. The people that ran these plants in the past had direct contact with those plants for years. There was a lot of longevity for our hourly workers, the ones in the trenches. They got to know the equipment, and they also did maintenance on the equipment that they were operating. They were building up years of experience, and the people that have been in this industry over the long term are now really retiring. They're aging out. We're losing a lot of that institutional knowledge as they retire, and we have not been good as an industry replacing them on a regular basis to know that people are following in their footsteps. So we're losing people, and we are losing that experience. At the same time, our equipment is getting older. It is very well built, especially the older pieces. But as they get older, it becomes harder to repair them. It becomes harder to find parts for them. We're even finding it's hard to find machinists who are able to work on them because the machinists themselves are aging out and retiring. So these are what we're seeing, reliability-wise, as we're trying to keep this equipment running. But we are doing things to try to help with our PDM. We do manual currently. We were doing manual vibration. We would bring in technicians. They'd go on a route, do the major equipment. And we'd get monthly or every other month readings to try to develop a trend, or at least see if we have a problem developing. We would also do oil analysis on the major pieces. And that was hit or miss because, they'd say, well, the next time, you're doing a PM on this gearbox, get a sample. Then you find out that the sample wasn't taken, you missed an opportunity, and there's a lot of that going on, as I think Suzanne mentioned, a lot of missed opportunities sometimes collect data. So, I was looking for something that would get us, more data on a regular basis. And before I got with KCF, I was actually running a pilot on a different machine diagnostic company's system, which was a wired system. It was cumbersome. It was taking a long time to install. It had promise, but it was cumbersome. So while we were in the middle of that, I think I was contacted by Brady. Hey, would you be interested in looking at our machine diagnostics? And I said, sure, but I'm open for anything. So we got to talking. As they described what was involved in the installation, it was, so different than what I was already becoming involved in. And I said, yeah, we got to try this. So we ran a pilot at our mill. This is our fine grind mill in Annville, Pennsylvania. It's part of our industrial minerals line of business, and we make material for fillers for roofing shingles, animal feed, chicken grit, things that require a high calcium content. This mill is on the site of another quarry. That quarry was opened in the early 1880s, actually. From the time it started mining until where it is now is 6 miles long. It's been backfilled about 4 miles of that, but there's still about a 2-mile open pit at this site. So there's a lot going on at this site, and this is actually just one small piece of it. But the whole process is pretty much inside the building. Down here is the dryer system, where we take the raw feed, dry that down to about close to 0% moisture, fed in, goes up a bucket elevator, more about that later, and then into the grinding and classification system. Here's a process flow diagram for that. Basically, we put the sensors on just the key pieces of equipment in there, the high horsepowers, those without anything without redundancy on it. And we try to keep it simple because it is a pilot. So many of you are probably already familiar with these. We use their small wireless sensors, which were ideal, one being wireless, 2 being magnetic. They were very easy to put on. For the most part, many could be put on without having to take off guards. And those that we did have to take off guards, it was, once it's off, you snap it on, we're good to go. As I said, we spent weeks wiring up our other pilot at a different plant. I think we were totally done on this in 2 hours. And it was, fired the plant back up, we were getting data by the end of the day. One of the hub systems, again, 120 volts, you plug it in, couldn't be easier. So this is our main blower, called PC1. This conveys our primary product from the grinding process to the truck filling silos. In the far photograph, you can see how we usually did it. Technician goes around, measures the bearings. We get a report the next day, and you compare it to the previous month, and they throw in some commentary. It was useful, but it was once a month. Now, 24/7 data coming from all the major bearings on this unit, and the motor. It's a 400 horsepower motor. You don't want to be replacing those too often. Some more examples, both outside the guards and even inside the guards, and they are small enough that even where guarded, it fits pretty well. Again, nice and snug. We also put it on our main mill. It's a Bradley mill, 600 horsepower. It's a vertical roller mill, so rock, call it 2-inch by 0, gets dumped in. 3 very large grinding wheels continually circulate over that, pulverizing it while you run air to aerate and elevate the finer particles, which are a possible product. That itself comes from another 400 horsepower fan up into a classifier, which only lets the finest particles through. So as you can see, we got sensors on both end bearings for the 600 horse motor. Very simple. Main baghouse fan. This one's always been a problem. So it was really good to get some 24/7 monitoring on this. And this is the classifier I talked to you about. Everything, all the main product goes through this system. Though it's only about 100 horsepower, it's a high-speed classifying ring. The bearings see a lot more abuse on this because of the speed. So we were able to tuck a sensor in there as well. And so, as I said, pretty soon we were starting to get data. I think within a few weeks, we were starting to see a problem on the roots blower, the PC1. You can see where it starts spiking up there. KCF got a hold of us because at that point we were not really reviewing it on a regular basis. It was still even new for myself and Dan Knight, our other maintenance person for the plant. But once they alerted us to it, we realized this is serious, we need to get on this. We did have a spare blower that was ready to go, and we were able to schedule an outage so that we can change that out, and we brought that right back to normal conditions right after that. This is another win. This is, I think, 2 months after we had it installed on a bucket elevator. If you remember from that first picture, even though that's supposed to be regularly inspected, you can bet that the few people that we do have to run the plant are not going to be really eager to go up and down the ladders and stairs it takes to get up there, especially in bad weather. So it's probably more neglected than most of the equipment that's inside the building. So, again, we got an alert saying that motor's starting to show signs of distress. We can see the trending getting worse and worse. So there was something we were able to schedule out a replacement, bring in the crane. We could do it at a normal time. As you know, these kind of things usually happen at 2 a.m. on a Saturday night. And no one wants to go through that. So, major win for us and for everyone at the plant too, to be able to do this scheduled. And we can get some other stuff done knowing that we were going to go down for the elevator motor. So where do we go from here? The pilot to us was a great success. And now I am planning on rolling that out to our other plants at Pennsy Supply. The majority of our plants are aggregate crushing plants. This is an example of one. This is in Mechanicsburg, Pennsylvania, about an hour and a half south of here. It does about 800,000 tons a year of aggregate. It supplies stone to our hot mix asphalt and ready mix plants, which are also on site here. And the key to as all our plants is reliability, making sure we have stone on the ground, quality stone, and plenty of it to feed not just our customers, but our internal plants as well. So these systems will have great effect, just as we've seen for the mill on our other lines of business. and at our other industrial mineral plant. This one is at Thomasville. This one is also about 800,000 tons a year of high calcium limestone. This one is completely underground mining. So there's another level of safety and engineering involved with this one. This plant was started in 1901. We have equipment there that dates back to the 1940s. It is a bear, and there's no other word for it, but it gets the job done, and we're doing everything we can to keep that existing equipment rolling. These sensors, we think, will be a boon to enable us to keep that going. And so why are we doing this? To avoid this. If those of you who have large pieces of equipment and you've got to tear them down to get at the innards, this is a secondary cone crusher, hardly even the biggest piece that we have here, but we needed to change bearings in this, and if we can avoid getting to this point for a whole range of plants, that's where our payback is going to be, and I think we're going to be seeing that. So in summary, what are we seeing out of this? What are we getting? Ease of installation and setup was what drew me in the first place. Obviously, the 24/7, 365 monitoring will enable us to find problems that we were not finding in our other ways. And then because of that web portal and the dashboard, we have immediate access to all that data, plus the KCF analysts who are monitoring it as well and giving out alerts. Really are a benefit to making sure we stay reliable. That's what I have. Thank you.
Thank you, Larry. So much tribal knowledge associated with the way you run equipment. I was asking Larry yesterday, I said, that one workstation or gearbox, it was from 1945 that you showed on your screen.
1948, right.
1948, there we go.
It was the primary crusher.
Okay, the primary crusher, and
yes.
I asked Larry, and I'll ask you again, the people who know that machine best, are they still on this side of the dirt?
We have two.
Okay.
But they've been with us for about 45 years.
Yeah, okay.
So, but they're close. They're close
to
going out.
retiring at least, right?
Yep.
The point is, I think we all, show of hands, who in here is struggling with labor shortage? Yeah. I think a lot of people have both hands in the air. Yeah. We do too, right? So the question is, when you look into the future, post-installation, you now have your plants digitized and connected, as you described. How do you think that's going to impact the day-to-day life of your maintenance techs? What's the difference for them?
Well, I've been thinking about this because when I first roll this out, I think it's going to be a nightmare. I see us putting all these sensors out, and all this old equipment that has, not been monitored this tightly suddenly flashes like Christmas trees saying problem, 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 problem. And I think we're going to be busy like firemen trying to get things changed out before it gets worse. And then I think it'll settle down. And then I think we're going to start enjoying the fruits of seeing that predictive maintenance and getting ahead of it. And with the, we have a very small workforce. It's been, maintenance-wise, it's been declining. It's really hard finding new people. We're starting to make a small dent, but we got a lot of equipment. It's hard to stay on top of it. Yeah. But I think with that, we will be able to schedule ourselves and avoid some of these fire drills that
much as Suzanne described with Toyota. Yeah. The first step of the journey after the technology is deployed is putting out the fires that we didn't even know were there, right? Catching failures and addressing the stuff that is about to fail. Then it becomes Kaizen, a continuous improvement process to further optimize and smooth out not just the machinery, but the life of those who service it, right?
That's right.
Terrific. Let's thank Larry.
Okay. Thank you.
Well done. Thank you.